Hi, welcome to AVM Math Hub. Today I'm discussing about the topic complex numbers. The first problem is if x is equal to 1 plus I root 2, then we have to find x power of 6 plus x power 4 plus x square plus 1 is equal to how much? We know that the complex number is in the form of z is equal to x plus iy. X is the real part and y is the imaginary part. So here, given that x is equal to 1 plus I by root 2. Now x square is equal to 1 plus I whole square by root 2 whole square. This is in the form of a plus b whole square formula. A square plus b square plus 2ab square and root cancel divided by 2. 1 plus I square value minus 1 plus 2I by 2 plus 1 minus 1 cancel, that is equal to 2I by 2. 2 cancel. Finally, we get I value. Similarly, x power 4. X power of 4 can be written as x square whole square. X square value I and I square value minus 1. And x power 6, that is equal to x power 6 means x square whole cube. X square already, x square value is I. So I cube. I square into I. I square is equal to minus 1 into I. That is equal to minus I. Therefore, x power 6 plus x power 4 plus x square plus 1 is equal to x power of 6 means minus I plus x power 4 means minus 1 plus x square value I plus 1, that is equal to plus 1 minus 1 cancel, I minus I cancel, the value is 0. And the next problem, find the conjugate of 1 plus I whole cube. We know that a plus b whole cube formula. A cube plus b cube plus 3a square b plus 3ab square. Therefore, 1 plus I whole cube is equal to 1 cube means 1 plus I cube plus 3a square b plus 3ab square. 1 plus I cube means minus I plus 3I minus I square value minus 1. So minus 1. So minus 1 plus 1 cancel. The value is plus 2I. The value is plus 2I. Sorry, here I square value minus 1. So this is minus 3. So minus 2 plus 2I. The value is minus 2 plus 3I. And the next problem, if 1 plus I into x plus iy is equal to 2 plus 4I, then the value of 5x. So we can multiply these two complex numbers. 1 plus I into x plus iy, that is equal to 2 plus 4I. That implies 1 into x, x plus iy plus ix minus I into iy, I square into y, I square value minus 1 into y. That is equal to 2 plus 4I. That implies x minus y real part plus take common I x plus y. That is equal to 2 plus 4I. Comparing real part and imaginary part. Real part means here x plus y, x minus y. Here real part value is 2. And imaginary part x plus y is equal to 4. Solving these two equations, we get x value. That implies x is equal to 3. Therefore, we have to find only 5x value. 5x is equal to 5 into 3. That is equal to, the value is 15. And finally, the fourth problem. What is the modulus of 4 plus 2i by 1 minus 2i? So, the complex number z is equal to 4 plus 2i by 1 minus 2i. Here, the denominator is also a rational number. So, we can rationalizing with the opposite sign, 1 plus 2i. 1 plus 2i by 1 plus 2i. That is equal to 4 plus 2i into 1 plus 2i by a plus b into a minus b. That is equal to 1 minus 4i square. That is equal to, we can multiply 4 into 1, 4 plus 8i plus 2i plus 2 to the 4 I square value minus 1 divided by 1 plus 4 I square value minus 1. 4 plus 8i plus 2i minus 4 by 5. That is equal to minus 4 plus 4 cancel, 10i by 8. 10i by 8. So 10i by 5. 5. That is equal to 2i. Therefore, modulus of z. Modulus means mod z value. So this is z value. Mod z means square root of. So this is also in the form of complex number. 0 plus 2i. 0 square plus 2 square. That is equal to 2 square. 0 plus 4, 2 square 4. Root 4. That is equal to 2. The value is 2. And the next. What is the value of I square I power 4 plus I power 6 plus and so on? Solution. I square power I power 4 plus I power 6 plus I power 8 plus and so on. The last two numbers, I power 2n minus 2 plus I power 2n. That is equal to I square value minus 1, I power 4 value plus 1 plus even number, power law even numbers. I power 6 minus 1 plus 1 plus 1 plus minus 1 plus 1. All are cancelled. The value is 0. And a set of complex numbers is denoted by the set of set. Set means denoted by complex. C is the set. This is the heart of the mathematics. The complex numbers is in the form of a plus ib or x plus iy, where a comma b are always real numbers and I square value is equal to minus 1. So this is the definition of the complex number. And the next one. Let x comma y belongs to capital R, then x plus iy is a purely imaginary number. If so, the complex number is in the form of x plus iy. We can write the purely imaginary number. That means x is equal to 0 and y not equal to 0. Purely, here I wrote only purely imaginary number. So the imaginary number is always not equal to 0. The real part is equal to 0, no problem. So whenever the values x is equal to 0 and y not equal to 0, that is called the purely imaginary number. And next problem, 8th one. A plus ib form of a complex number. Then the value of 1 plus 2i into minus 2 plus I, that is equal to 1 plus, we can multiply both values, minus 4i plus 2i square, that is equal to 1 plus minus 4i minus 2, that is equal to 1 minus 4i plus into minus 2 minus 1 minus 4i. So this is the answer. And next problem, additive inverse of 1 minus I. The additive inverse is additive inverse of 1 minus I, that is equal to, here the real part is only positive value. The additive inverse of real part is minus 1. Here the value is positive, then we can write the negative. And the imaginary part value is minus I. Ikkada imaginary part minus I on the negative minus on the additive inverse emotundante plus I. So this is the additive inverse. And the next problem, if z is equal to minus 1 minus I, then the argument of z is dash. Given z is equal to minus 1 minus I. Here the values x is equal to minus 1, y is equal to minus 1. Therefore, argument of z is equal to, the formula is, if x plus iy is the complex number aithe, therefore argument of z is equal to formula tan inverse of y by x. So here also we can write tan inverse of y by x, that is equal to tan inverse of minus 1 by minus 1, that is equal to tan inverse of 1. The value of tan inverse of 1 is equal to pi by 4, 45 degrees. So this is the answer. And the next one is, the value of root I is very, very important. The value of root I is, we know that I is equal to square root of minus 1. Let square root of I is equal to a plus ib. I is equal to a plus ib whole square, squaring on both sides. I is equal to a square plus I square b square plus 2abi, that is equal to a square minus b square plus 2ab into I. Here a square minus b square is equal to 0 and 2ab is equal to 1. 2ab ఇక్కడ I ని 0 plus 1i రాసుకోవచ్చు. సో దిస్ ఇస్ అ కాంప్లెక్స్, అంటే కంపేరింగ్ కోఎఫిషియన్స్ కాబట్టి 0 plus I నే 0 plus 1i అన్న ఒకటే. సో దీంతో ఇక్కడ రియల్ పార్ట్ తో ఇమాజినరీ పార్ట్ తో కంపేర్ చేసుకున్నాను. సో a square minus b square is equal to 0, that is equal to a square is equal to b square. Here 2ab is equal to 1, that implies a is equal to 1 by 2b. Here a square is equal to b square, that implies substitute a value. 1 by 2b whole square is equal to b square. That implies 1 by 4b square is equal to b square. That implies 1 by 4b square, లేకపోతే b power 4, b power 4 is equal to 1 by 4 లాగా రాసుకోవచ్చు. Therefore, b is equal to plus or minus 1 by root 2. Therefore, a is equal to b. కాబట్టి plus or minus 1 by root 2. That implies square root of I is equal to plus or minus 1 by root 2 plus I into 1 by root 2. This is the value. And 12th one is find the value of I power 108. Here we know that I power 0 is equal to 1. I square is equal to minus 1. I cube is equal to minus I. And so on. I power 4 is equal to 1. Therefore, I power 108 can be written as I square of 254s. So I square value and minus 1. Minus 1 whole power of 54. ఎప్పుడైనా పవర్ లో ఈవెన్ నెంబర్ కనుక ఉంటే మైనస్ కాస్త ప్లస్ అయిపోతుంది. ఆడ్ నెంబర్ ఉంటే మైనస్ గానే ఉంటుంది. ఓకేనా? అండ్ నెక్స్ట్ వన్ ఈస్ if z is equal to 1 minus I, then the principal value of argument of z is given z is equal to 1 minus I. Here the given point z lies in the fourth quadrant. ఎందుకంటే 1 minus I is in the fourth quadrant. Here the given point z lies in fourth quadrant. Therefore, argument of z is equal to formula tan inverse of y by x. Y value enta x value 1, y value minus 1. So minus 1 by 1 రాసుకోవచ్చు. That is equal to tan inverse of minus 1. That is equal to tan inverse of minus 1 అని minus tan pi by 4 రాసుకోవచ్చు. Tan inverse, this can be written as tan inverse of tan minus pi by 4. Tan inverse of tan theta is equal to theta minus pi by 4. The value is minus pi by 4. So here the z value, the complex number z is equal to 1 minus 2i. The point z lies on the fourth quadrant. Already we know the formula about argument of z. Tan inverse of y by x, here x and y. Substitute y by x values and finally we get minus pi by 4 values. Okay, tomorrow we'll discuss from 14th problem onwards. Thank you so much. Have a nice day.